In today's video, we will be discussing definite integration area. This is the section 5.11 of the IB Math AA essay curriculum. So previously, we have discussed indefinite integration, and we are today discussing the definite integration. So with the definite integration, when you think about indefinite integration or the integration that we did before or prior to this section, we always end up with an equation, right? But with the definite integration, we can solve, or we will end up always with a number, right? And also one of the ways that we can use definite integration is to find out the areas between the x-axis and the function that is available, or the area between two functions. Okay, so to calculate the area, this is our main purpose of this section. So to calculate the area with the definite integration, we always need to know how to calculate this manually and also using GDC. Okay, so the first thing that we're going to do today is the manual process of the definite integration. That's what we're going to discuss. Okay, so in essay 5.5, we have discussed what a definite integral is and how to find it, and the area under the curve using GDC. So in this section, we will discuss how to find the definite integral by hand. Okay, this is solely for paper 1. Okay, so your Math AA paper 1 exam is no GDC, right? You cannot use GDC, so you need to know how to do this manually or by hand, right? So to calculate to perform the definite integration, we have to use this formula here. Okay, your formula booklet have this in the most simplest way. Okay, so I suggest that you remember this formula. Okay, so or what I mean by this is, if there is a range between a and b, or if the x value is between a and b for the function g prime x, when you integrate this is same as g of x. X value range from the a to b, so means we have to subtract g of a value from g of the b value. This is simple as this one. So let's try the example number 1 right away. So we need to find this integral where the x value is from 0 to pi over 3, and we need to integrate sine x dx. So first thing, when you integrate the sine x, it becomes negative cosine x, right? Plus c. However, just purpose of this example, we will ignore plus c for now. Okay, so integration 0 to pi over 3 sine x dx is same as negative cosine x, the x range from 0 to pi over 3, and this is same as bracket negative cos pi over 3 minus negative cosine 0. Okay, then we know that cosine pi over 3 according to unit circle, right? So you need to remember the unit circle. So according to the unit circle, cosine pi over 3 is same as 1 over 2. So the first part is negative 1 over 2. Cosine 0 is same as 1, so means we have negative minus 1. So we have negative 1 over 2 plus 1, which is same as 1 over 2. So we can say that when x value ranges from 0 to pi over 3, and integration sine x dx is same as 1 over 2. Okay. Then let's look at example number 2. We need to find the area under the y equals x squared plus 2 between x equals 1 and x equals 3. Okay, so we are trying to find the area under y equals x squared plus 2 between x equals 1 and x equals 3. We are not sure about how the graph looks like. However, we already know that the range is from 1 to 3. So we're going to use this formula right away. Okay, so this becomes 1 to 3. The x value is from 1 to 3. And then we have function x squared plus 2, and we need to integrate this. Okay, so this is same as x cubed over 3, or we can say x squared plus 1 over 3 plus 2x over 1. The range is from 1 to 3, right? Then this is same as x cubed over 3 plus 2x. The range is from 1 to 3. And we have 3 to cube over 3 plus 2, 3 minus 1 to power cube over 3 plus 2 times 1. Then this simplifies into 27 over 3 plus 18 over 3 minus 1 over 3 plus 6 over 3. And this is same as 45 over 3 minus 7 over 3, which is same as 38 over 3. That's how you do definite integration with the simple examples like this. Okay, then let's talk about why we are learning the indefinite integration. With the indefinite integration, we can calculate the area between x-axis and the graph, and you also need to know how to calculate the area between two graphs. Okay, so the first thing that we're going to talk about here is the area between x-axis and the graph. Okay, so when identifying the area under the curves, we need to be careful of the regions below the x-axis. So as the integral, we naturally give you the negative values for the area, which is clearly wrong. So if we take absolute values of each region between the roots of the b over a to b, absolute f of x dx on GDC, we can ensure a correct area. So this means when we are calculating the areas between the x-axis and the graph, there is chance that we sometimes get the area like this on the positive side, but also on the negative side. So since we need to calculate, since we need to consider that negative side area, we need to put the absolute value around the function. So if you look at example number 1, we need to find the area enclosed by f of x equals to x cubed minus 4x squared plus x plus 6 and the x-axis. Okay, this is a GDC question. You can substitute this into your GDC, and you first have to find the roots to figure out what are these points, or what is the points that encloses the area between the graphs and x-axis. So when you use GDC with this function, we can identify that the zeros are the negative 1, 2, and the 3. Okay, so we know that we need to identify the area between negative 1 to 2 and 2 to 3. So these are our range first. So we have to do integration, negative 1 to 2. So we are referring to this area here. After that, we have to do integration from 2 to 3, which refers to this area here. Okay, so we do absolute f of x dx, absolute f of x dx. Okay, then let's try to integrate the f of x first. Okay, so f of x, when you integrate this becomes x to the power 4 over 4 minus 4x cubed over cube plus x squared over square plus 6x. Okay, And since this is the definite integration, there's no c, right? So we don't have to worry about the c part. So then you can plug in this integrated formula into the equation. Means we can put the equation like this: x to the power 4 over 4 minus 4x cubed over cube plus x squared over 2 plus 6x absolute -1 to 2. We just identifying the range that we are using. And then again we do x to the power 4 over 4 minus 4x cubed over 3 plus x squared over 2 plus 6x, and we identify the range, right? Which is 2 to 3. Then right now I'm just going to show you how to do this manually. Then I'm going to show you how to do this using GDC. Okay. Then we're going to substitute -1 and the 2 into the equation. So for the first part, it becomes 2 to the power 4 over 4 minus 4 times 2 to the power 3 over 3 plus 2 to the power square over 2 plus 6 2 minus 4 over 4 3 plus -1 to the power 2 over 2 plus 6 times -1, and we do plus 3 to the power 4 over 4 minus 4 times 3 square over 3 plus 3 to the power 2 over 2 plus 6 times 3 minus 2 to the power 4 over 4 minus 4 times 2 to the power 3 over 3 plus 2 to the power 2 over 2 plus 6 times 2. Then this gives us the values of the 45 over 4 plus 7 over 12, which is equal to 71 over 6. So this is how you do it manually. Okay, then let's talk about how to calculate this using GDC. Okay, so our function is still f of x equals x to the power 3 minus 4x squared plus x plus 6. Okay, and the integration is supposed to happen in this way. Right? Then let's talk about how to substitute this into GDC. Okay, so on your calculator screen, like this one here, okay, again, you're going to place your cursor on the bottom part, right? Then here, you're going to click Math tab on your GDC, okay? After that, you're going to click 9 FNINT. This means finite integration. Okay. Once you click these two buttons on your GDC, you will see on your screen a template that looks like this. Okay. Then on this template, you're going to substitute your first equation. Okay, then you're going to put -1 here, 2 here, and don't forget to put absolute, right? So at this point, I think your question is like, how do I put the absolute sign on my this template function? You have to click Math tab again. After that, click Number tab on that screen, or move to the number list on your screen under the Math tab and click absolute. Okay, then it will automatically insert the absolute signs on your GDC where this template is happening. Then you will see another square inside the absolute signs. Then here you substitute your function. So x cubed minus 4x squared plus x plus c, and substitute x into your dx part and hit enter. Then you will get the answer for the first part of the equation. Okay, Then you do this again for the second part of the equation using the same keystroke, but this time the range will be different, right? 2 to 3, absolute value, again, same equation. And you put x on your dx and hit enter. Then you will have the answer for the second part of the equation. Then you add them together. Okay, you get probably 45 over 4 for the first one, and then 7 over 12 for the second one, and your total will be 17 1 over 6, or depends on your calculator, it will give you 11.8 as the final answer. And that's how you use the GDC with the definite integration. Then now let's talk about the areas between the curves. Okay, I cannot be 100% sure about this. You probably going to get a question about a function and area between a function and x-axis, or the areas between the curves on your GDC paper or paper 2, right? Or paper 1 if the functions are simple enough. So it is very crucial that you study this section, right? So, and remember, with the calculus section, there's not much thing to talk about it, right? Or not much sections that they can make a question, a proper question out of it. It's going to be either tangent, line of tangent, or normal line, or the areas, right? Using the integration. So make sure you practice it, and let's talk about the areas between the curves. So we can find the area between the curves by using the fact that the area under f of x subtract the area under the g of x. Okay, so this is the crucial part. So when we calculate the area under the curves, we always assume that the function that has a that took over the higher position on the Cartesian plane subtracts the other function that took the place on the lower side of the Cartesian plane. So means if we have a function, let's say we have a function like this, okay, and then another function like this, okay. So then let's say the red colored one is g of x, the blue colored part is f of x. So in this case, you can clearly see that the f of x actually took the higher part of your Cartesian plane. So it takes all these places. However, when f of x subtract the g of x, which takes the lower part of your Cartesian plane, when it subtracts this part out, you can see that the only part left is this area between these two curves, right? So that's the reason why when we try to calculate the areas between the curves, we always subtract the g of x from f of x. However, we cannot just subtract them, right? We always need to have a certain range to have a proper value. So in this case, in this example's case, you can see that there are two intersection points between the function f of x and the g of x. Then we can say the first intersection point has the x coordinate of the A, and that the second intersection has the x coordinate of the B. Then we can clearly say that the area between these two graphs lies between the range A to B, right? Okay, then we can say that the range for this integration process is A and B, and we can calculate the area between these two graphs by subtracting the g of x from the f of x, like this. And also this can be rewritten in the simplest form as a to b f of x minus g of x times dx. Okay, then let's try to use this formula to calculate the areas between the curves. Then let's try to calculate the areas between the curves using this formula. So when you look at this example number 4 here, we need to find the area between y equals x cubed and y equals x squared minus x between the x equals 0 and the x equals 1. So we have our range already. So they are x equals 0 and x equals 1. Okay, and we want to calculate the area between y equals x cubed and y equals x squared minus x. So when you have a polynomial function that has a power greater than 3 in your equation, like this case here, it's going to be probably a GDC question, right? So I already got the graphs out for you. So if you have a y equals x cubed graph, it's going to look like this, okay? And if you have a y equals x squared minus x graph, it's going to look like this, okay? And the question says that the range is happening between the 0, the origin, and the 1, which is where this red graph is probably intersecting the x-axis. So we have to calculate the area here, okay? So again, since we know that the top graph is y equals x cubed and the bottom graph is y equals x squared minus x, we can subtract the y equals x squared minus x from the y equals x cubed, okay? So we are still doing x cubed minus x squared minus x to find the area between the graphs. So once again, we know that the area under the y equals x cubed between the x equals 0 and x equals 1 is this part here, okay? If we subtract y equals x squared minus x between the x equals 0 and x equals 1, which is this part, we can calculate the area between the two graphs, two functions between the 0 and 1, which is the yellow part, okay? And this is the part of the function, and the complete equation will be integration, the range 0 to 1, x cubed minus x squared minus x times dx, right? At this point, you can use your GDC to calculate it, but let's try manually as a practice. So 0 to 1, so we have x cubed minus x squared plus x times dx. So we're going to integrate the function first. So we get x to the power 4 over 4 minus x cubed over cube plus x squared over 2, 0 to 1. And this is same as 1 to the power 4 over 4 minus 1 to the power 3 over 3 plus 1 to the power 2 over 2 minus 0 to 4 over 4 minus 0 to 3 over 3 plus 0 to the power 2 over 2. Then this gets simplified into 1 over 4 minus 1 over 3 plus 1 over 2 minus 0, and the final answer is 5 over 12. Make sure you check your GDC. Make sure you use your GDC and see whether you get the correct answer, okay? So make sure you use the GDC to see whether you have the same answer as when you did the manual process, okay? Then let's try an IB question. So here I have a question number 1 from the example paper, paper 2, essay, time zone 0, and the question number 6. So we need to consider the curves y equals x squared times sine x and y equals negative 1 minus square root 1 plus 4 times x plus 2 squared for x values between the negative pi and 0. So before starting this question, you have to check your condition of the GDC, right? This is paper 2, so you're going to use the GDC, and your GDC needs to be in radian mode. Why? Because your range is given in radian, okay? So question A, we need to find the x coordinates of the points of the intersection of the two curves, which is the y equals x squared times sine x and y equals negative 1 minus square root 1 plus 4 times x plus 2 squared. So if we are doing this manually, we have to set x squared times sine x equals to negative 1 minus 1 plus 4 x plus 2 squared. Okay. However, this is a GDC question. So here I have your GDC screen. So on your GDC screen, you're going to click y equals tab first. So y equals tab. That's your first graphing tab, right? And you're going to substitute x squared times sine x as your first equation right here. Okay? And you're going to substitute -1 minus square root 1 plus 4 x plus 2 squared as your second equation. Okay? Then you graph it. So next you need to graph it. So using this button here, right? Then make sure your range is, your x value range is between -pi and then the 0. Once you've done this, you can use the, you can find the, once you've done this, I'm pretty sure you know how to change the range, right? Using the window tab, right? So using the window tab, change the range of the x values. Then use the calculate button, calculate your intersections. Okay. Then you will get x values equals to -2.76 and -1.54. So these are your range for your integration process. So question B, we need to find the area A of the region enclosed by the two curves. So from the question A, we know which graph is higher, or which function is higher, right, already. So we're going to do integration. The range is from -2.76, -1.56. The larger negative number is smaller, right? Then we're going to do absolute. We're going to subtract the lower function, which is the -1 minus square root 1 plus 4 x plus 2 squared, from the x squared times sine x and dx. Once you do this, using your GDC, do you remember the keystroke? So math tab, and we do 9 finite integration. Then we can get this template, and we just have to do this. We just have to substitute the numbers, right? So once you've done that, you will get the final answer, 1.47. And that is the end of this section, and this is also the end of the topic 5, IB Maths AA Essay Curriculum.